Hi, my name is Ale Castillo, and today I will be talking to you about the differences between Texas and Montana's water usage. Texas and Montana might seem like they're worlds apart, and when it comes to water use, they kind of are. Texas is the second most populous state in the U.S., with major urban centers, manufacturing plants, and a heavy reliance on thermoelectric powers. All of this requires a massive amount of water. Montana, by contrast, is sparsely populated, with most of its land used for agriculture and ranching. While Montana does not have much water overall, more than doesn't use much water overall, it has irrigation withdrawals because of its extensive farming industry. These differences reflect not just geographically, but also economic activity, energy production methods, and population density. Now, what is my objective? What am I trying to find out? I am trying to aim to explore and compare how two very different states, Texas and Montana, use water in terms of total consumption, categories of use, and sources. I want to understand the reason behind the differences of the water usage and how they relate to each state's climate, population, industries, and energy sources. Now, my objective is also to highlight potential opportunities for water conservation by learning from each state's strategies. Now, what is my research goal? It is to compare and understand water withdrawal categories and total use in Texas and Montana, discover how population size, energy sources, and climate shape water needs in each state, to investigate how different industries like agriculture or energy affect water consumption, identifying potential efficiencies or improvements that one state might adopt from the other. What is my methodology? How did I get my information? Water use information came from the U.S. Geological Survey from 2010 reports, which are publicly available and reliable sources for historical water use data. I analyzed you, sorry, I analyzed usage in multiple categories, including public supply, domestic irrigation, livestock, aquaculture, industrial mining, and thermoelectric power. I also examined where the water came from, which is groundwater, fresh and saline, and surface water, fresh and saline. I converted all the data into million gallons per day, or MGD, for consistency and ease of comparison. I also used Microsoft Excel to organize and clean the data, and generated bar graphs to visually represent water use by category and by source. Now, if we go ahead and look at the first graph, it is going to tell us our total water usage. If we go ahead and look at Texas, we can see that it is overwhelmingly using more water than Montana. And if we were to go ahead and add all of the usage that Texas were to have, we'd go ahead and get 29,300 million gallons per day. Now, if we look at Montana, it only has 10,000 million gallons per day. Uses nearly three times more water than Montana. This is largely due to its larger population, urbanization, and heavy reliance on water intensive industries such as thermoelectric power. Montana, while using less overall, dedicates a significant portion of its water to irrigation, which is critical to agricultural economy. Now, if we were to go ahead and take a look at graphic one again, where does the water come from? Texas pulls more surface water, especially from fresh water from rivers and lakes, to meet its growing demands. Montana's water source includes both surface and groundwater, um, though on a smaller scale, and tends to be more locally managed. Saline water withdrawals are more common in Texas, especially in energy production. These differences are due to regional water availability, infrastructure, and state level policy priorities. Now, if we were to go ahead and look at the second graph, we can see that Montana had more water withdrawals in irrigation relative to its size, which reflects its strong agricultural focus. Now, Texas uses thermoelectric power sector, which dominates its water usage, especially for cooling systems and power plants. Um, Now, domestic and public supply use is higher in Texas due to its larger population and urban infrastructure. Montana's water use is concentrated in fewer sectors, but it's still substantial in scale due to its expensive farmland. Now, what else could we learn from future studies? Future studies could focus on how climate change may shift water availability and usage in both states. New irrigation technologies and smart farming tools could offer water savings, especially for agricultural heavy Montana. Texas could explore how greater shifts towards renewable energy could decrease its heavy reliance on water for thermoelectric cooling. Cross state policy comparison might help improve water sustainability practice and emergency drought planning. And finally, studying how water rights and governance vary across states can also offer additional insight into long term water access and conservation. I also included my references at the bottom right of the page. Thank you so much for listening.